Oh, no, it wasn't done yet. Darn it. Oh, well, next part of the lesson, I'll just crop them together or something. Okay, here is your actual lesson for today. Keep in mind the input output we just saw. So this is Silent Board Game. I'm gonna ask that you guys pay attention. Grab your sibling or something and see if you can follow along with what I'm doing here. Here we go. Okay, so this movement, when rectangles are changing like this, changes the area. And eventually, when it gets thinner and thinner and thinner again, the area is gonna go back down. It starts off with no area, the area grazes, and then it gets smaller. So there's an equation for this, and the area equation is always base times height. And this is what we were doing the other day. Base times height. And so I can make up an equation for this. The base, I'm gonna say, is whatever number. Every single time the base is some number and the height is another number. And then I can make up a second equation. And we haven't done this yet. What? Okay. I'm gonna make up a second equation and see if this also makes sense to you. Okay, so one way that you're taught how to do this sometimes, do you agree that this always has to be true? This is the constraint I gave myself. Like, no matter what, we always have to have 12 and 12. So what a student can do is just solve for h and plug it back in. This is a system of equations. So I'm gonna do a little bit of math. The way that we used to, I'm gonna use substitution method. So I'm gonna subtract 2b from both sides. I have 2h equals 12 minus 2b. And then I have to divide by 2 to get h by itself. So now I have, if I want to simplify this, 12 divided by 2 is 6, 2 divided by 2 is 1, and this is always the height. The height is always 6 minus the base that I chose. So I'm going to use substitution method. I'm going to plug that back into my area equation. So instead of area equals BH, I have area equals base times this h, 6 minus b. I'm so sorry, 6's and b's look almost exactly the same. That was a bad choice. Base. I'll make my base capital B now. This equation is a parabola. So this is 6 capital B minus b squared, the base squared. And if I graph this, I get a parabola that's upside down. It has a negative, it's an upside down parabola. And I should be opening Desmos, but I don't have anything for you right now. This, just like what you did the other day, says right here, the coordinate point tells me something. Right here, if I input 0, meaning I have a 0 base, my output equals to is supposed to be my area. If I had 0 base, what was my area? 0. And then we do the same thing again. At base of 1, my area was 11. Now maybe I made this a little bit too high. But what happens that this is tracking over time is that as the base gets bigger, as my base grows, the area gets bigger, but then suddenly over here, the more I make my base, the thinner and thinner, and then my area goes back down again. And so here on this parabola, it literally represents as my base gets bigger, my area goes up, but then at a certain point, my area, the base gets bigger, my area goes back down again. And then it closes and it closes until finally, right here, I have 12 on the top, 12 on the bottom, and 0 area because there's nothing left. So I know that if a base were 12, that would be my last coordinate point. If I chose base of 12, my area would be 0. All of these areas, the area is getting more and then the area gets less. And so we actually use this, it's called mathematical modeling. We're modeling this function using a parabola. And it's really important that you know that on a graph, like if you plug this into Desmos, this keeps going. But this can't exist. We can't have more than 12 and we can't have negative area. So the x values more than 12 would represent a base more than 12. So if the base is greater than 12, it doesn't exist. That's not part of our domain. And so that's an x value that can't be more than 12, and then the y values can't be negative because my area can't be negative. My area has to be positive. So all of this like doesn't exist. That is your math lesson for today.